All right, we're going to get started now. This is going to be an amazing session. So excited to welcome Joe to the stage. Joe Ransegnola has been at Mongo for the past 2.5 years, but has over 10 years experience in software engineering and architecture, and is currently one of our search-focused solutions architects here. Please give a warm welcome up from Austin to Joe for Atlas Search.
Hey, everyone. How are you guys doing? Hopefully I caught you after you got your coffee. And I know I'm the session before lunch, so I'll try not to keep you guys over. But yeah, I do want to just introduce myself. I'm a senior solutions architect here at MongoDB. And I'm responsible for probably talking to many of you on the phone about best practices, deploying your MongoDB instances using EA or Atlas products. Today, I'm going to give a talk on search, how to get started, the overall architecture of how we do search, and why it might be better for your solutions. So let's start off with a simple architecture diagram. This could be something that you guys currently have in place. So maybe web or mobile, or maybe a background cron process that is writing data to MongoDB, you're persisting your data in MongoDB already, and you're looking for some way to offer search up on your platform, either with Elasticsearch, Solr, OpenSearch, one of those search engines, many search engines that exist out there. But there is a lot of problems and complications that come with doing something like this. You have to set up an ETL pipeline to shuttle data from Mongo to these search engines. You have to spin up the infrastructure yourself, manage the pipelines, monitor all of that. And it comes at a cost, both operationally and just as far as like maybe getting downtime or just keeping an eye on it becomes quite a pain. And that's just the physical costs. You have to think about consistency of the data. How often is my data being pushed from Mongo to my search engine to keep it updated so my clients can see the most recent data if there are any updates. And then you have to worry, like I said before, you got to worry about what if one of these connected pieces fails. So what if you could simplify all that? And that's kind of what we did with Atlas Search. So Atlas Search is a Lucene-based engine. It's a fork of it, actually. And it gets deployed with MongoDB. It can be created right on top of your data in Atlas already. So if you have an existing collection on, say, a product catalog, you could throw a search. You have your regular B-tree indexes that you can create in Mongo, and those are all well and good. But they kind of lack that text ability to search on and do fuzzy search and kind of give that Google experience that you've been wanting to give. Plus, like simplifying this architecture, putting it in Atlas made sense to us too, because you don't have to worry about the other pieces. It's there. It's really easy to use. And it just clears up all that complexity. So it's a lot less to worry about. So if you're familiar with how infrastructure works on Atlas, you'll know that we deploy everything in replica sets. So 3 nodes typically get the MongoDB process on their on each node, so that you have a primary where all your writes are coming into, all your updates, and then that replication out to the secondaries. And as this is constantly going on, your data is being redundant, highly available. You've kind of heard that spiel in the past. So when we add the Atlas search process in, we're actually deploying that Lucene process on each node as well. So what this does for you is not only gives you that additional functionality for search, for it to be able to access that lightning fast text search, but it also gives you the redundancy that you've come to know and be happy with as far as like just having replica sets themselves and really just not having to worry about like something going down and keeping 5 systems up and running. So how do you harness all this new power? Well, like I said before, you have this Atlas search process running on your node, each node in your cluster now. We're still going to work with the primary node. But let's take a look at how you access this. And you're going to use our aggregation pipeline. So somebody was looking for this before this morning, and then they were asking, well, how do I use search? It's the aggregation pipeline. It actually becomes the first stage in your aggregation pipeline with that $search function there. So I have a couple other functions. You can see downstream that we have, as an aggregation is passed into the MongoDB process, it's going to read that $search, and it's going to pass that search onto the Lucene function to run that search. And there's lots of operators, just as you would in Elastic or Solar, as far as like compound queries, fuzzy matching, boosting, all that stuff. You can throw that into that search stage. And then once those results are, pulled out of that Atlas search process, they are then passed to the rest of the aggregation pipeline to continue to do whatever manipulation you need to do. Whether it's maybe relevance from a search engine's not good enough, you want to do your own sort, or maybe you wanted to use search to drive some kind of web front end that has like a grid where you're allowing users to do custom sorts or something like that on the fly. You can absolutely do that with an aggregation pipeline and continue to pass down results from stage to stage so that you can get the results you want. Now, I will say here that adding a bunch of additional stages will slow down your pipeline, obviously, but if you're looking to maybe give that lightning fast autocomplete or fuzzy matching service, you can absolutely do that with just plain old search stage. So so now that we talked a little bit about the architecture, let's let that sit in for a little bit. Just want to quickly cover some additional reasons you might want to look at search. If you didn't notice me saying the word Atlas Search or Atlas Search Process earlier, I want you to get that through, that this is an Atlas-only piece of, a new process only to Atlas. So I'm sorry for our Enterprise Advanced customers. The reason we do that is largely so we can control the deployment, the updates of that Lucene process on the fly, and our product team's looking at offering more ways to integrate that into MongoDB and other places. But primary focus is for Atlas or Atlas for Gov right now. So if you're already using Atlas, you can get started pretty easily. It's very easy to just slap an index onto an existing collection, and I'll show that later in my demo. But if you don't have one and you were here for Leo's presentation earlier this morning, you can spin up one of our free Atlas clusters, an M0, and then you can start creating your search capabilities right there just to test it out, load some sample data, which is what I'll show you too. So the other thing I want to make clear too, it is for those of you who haven't used search before or a search engine, Lucene gives you results in a relevance-based manner. Everything gets a score. So we will always give you the results with the highest score first. So if you're thinking, oh, well, maybe I need to offer custom sorting like I do with my normal queries now, search is designed for relevance first. So just to get that out of the way. But it does give you the ability to do that like Google experience in your mobile app or your web app, or an internal app where you're allowing users to type as they go and start pulling back results from a MongoDB collection. Last point here is faceting. So faceting is one of the, we do this for, if you have a product catalog on MongoDB, it probably makes really good sense to have faceting as a part of it. If you've ever been on Best Buy or any of those websites where you see groupings of attributes, TV sizes or what have you, manufacturers. Faceting is really good to do with search because it can be up to 100 times faster than doing our regular facets with just regular MongoDB queries. So that's another good reason. OK, so a couple slides back, we showed that aggregation pipeline, that search stage. So I wanted to dive a little bit deeper into that $search stage and what's available there. And when I talk to clients, they're trying to do like one of three things. First one being, just having like autocomplete, doing that Google experience. Second one, having maybe a custom analyzer. And what that means is, maybe I would want to search on different languages, French or German. Maybe I'm offering something overseas. And then lastly is, being able to control that score. So like I said, relevance score, everything comes back with a score. You can add a boost to that so that you get a certain topic to the top. It's a very good way to start doing controlled relevance search. If you're doing, say, like an auto search, and you want to push, a certain car that month, maybe you're going to boost any searches for Ford Broncos or Teslas, something like that. So boosting is a great way to continue to manipulate that score, and we offer many, many ways to do that. There we go. So here's an example of that first situation where you want to give that Google experience. And when we do searches, there's two pieces that you need to know as a developer. One, creating the search index itself first. And you can see that on the bottom. So if I'm trying to do an autocomplete index, I'm going to add some certain, I'm going to pick what field I'm going to try and do that autocomplete on. I'm going to add the type of autocomplete to that index. And I define these mappings. And I'll kind of show this a little bit too in my demo. But you want to give some rails too. I put the defaults here, but once you create that index, then that field is ready to be auto-completed on. And then when you start passing into that search query, the field name that you created the mapping on, and then whatever the query is that the user is processing, they can get the results very quickly as they start typing. So every 3 letters, 4 letters as they start typing. Second one is a custom analyzer. So what I'm showing here is how to make your own. But what is used most of this, so when you create an analyzer is a part of an index. So for the very first time, we include Lucine's standard analyzer by default. But you can create your own. There's some others pre-built, like white space, keywords, or maybe, like I said, if you want to do a specific language or use more than one analyzer, you can absolutely do that. So we kind of give you the ability to customize it and use your own, as long as you're passing in a tokenizer, character filters, like I've shown here. There's nothing you need to do on the query side of the house for this, so that's going to stay rather the same. But customization is completely up to you. And there is a lot of documentation on our website on how to play with this. There are a lot of possibilities, so I would encourage you all to look over that, decide what you're going to do for the business or what you're trying to offer, and then maybe one of us can come and help you. But with custom analyzers as well, say you had HTML tags embedded into some text, and you're like, oh crap, I need to allow my users to search over this. Maybe they're searching for books or over websites. You could absolutely put an HTML parser in there as well to rip out tags, custom tags, or allow custom tags, and still deliver those text results to you. Last one is score manipulation. So a lot of people, the first time you experiment with autocomplete, I'm not going to lie, you're going to be like, why did I type in this exact word and it didn't pop up with autocomplete? And that's because the way autocomplete actually works, it's trying to take, it's going to score you based on matching every character. So when you want to match a complete token, like a complete word, you also have to add this compound operator here. So you'll see that in the example here, as far as if we were searching for Helsinki in the plot field, what we want to do is give the results auto-completed for finding Helsinki in a plot. But if we type in the whole word, we do want to match on the title as well and give it a boost. So an exact match on that full word does come to prominence at the top of your results. So it gives you, boosting in general gives you a lot of customization over, like I said before, if you're trying to boost a particular car or something for the business, or something you want your users to find more times than not, boosting is a great way to give that functionality there. Also in score manipulation, we have custom functions like Gaussian decay. There's again, the documentation is quite expansive on this. So if you're trying to do something specific, usually the best way to do that is to get on the phone with one of the solutions architects or one of our product team for search, and really just talk it out. Figure out what you want to do, and we'll direct you in the right way. So outside of those 3 features that I covered that are probably 90% of my calls with many of you, there are many, many more features hidden in search. So highlighting, if you wanted to specifically call out custom words in a sentence that are prominent. Faceting we talked about before, if you're doing logical groupings of attributes like like I mentioned before, TV sizes, manufacturer, that type of thing. Synonyms is pretty cool too. Synonym sits as a separate collection along with your index, can take really any attributes and map them in a like-to-like way. So if you're doing a search on Ford or a specific car manufacturer, you can make a synonym that relates to a car. So when a user types in car, they get Ford, Mercedes, Toyota, that type of thing as well. 30 supported languages. Geo search, so doing geo near a certain topic, or this is your Airbnb search as far as hey, give me everything within 30 miles of Disney World that matches this text. Geo search is great for that. Embedded documents, obviously because it's MongoDB is based on a JSON model, object model mapping, so we're going to have embedded documents. We're going to want to be able to search and tokenize fields in there as well. So that is also out. More like this. Kind of gives you that extra additional suggestions. Start searching for something. You might say, hey, more like this. Give me a couple of other articles in that collection that fit. And then dense vectors too. So this is more a recommendation in machine learning. This is something that we're currently working on, and we have a beta program called Dazzle. If you're interested in testing some of our brand new Atlas search functionality, Dazzle is a great way to get first access to that, create a little cluster, and do your own testing. But dense vectors will give you basically a three-dimensional score on the closeness and likeness of one word to another. And you can customize that as well. All right. So I spoke a bunch. Let's pop out and just show you how easy this is. OK. So let's go here first. So if you followed along this morning, you probably know how to spin up your own cluster. This is my free cluster. I put it on for workshops when I display it to customers. And this is really the easiest way to show how to build search. So if you haven't in your sample cluster loaded a sample data set, that's the first way to do that. So do that first. Jump over into your collections tab here. And this will, of course, everybody's online right now, so the internet's going to be slow. Demos never go the way you want. But once this loads, I'll show you really quick. So you can go to navigate directly to that collection and then build a search index right from there. And let me see if it shows. Love this. OK. I'm just going to skip over that piece. All right. So you have your search index created. It's very easy to create one from scratch. You're allowed 3 on your free cluster to play around with. So I already have 3 built out. But if I wanted to look at maybe how do you go about creating this, you can come out, create your search index with a specific analyzer. Like I said before, we offer a couple in from scratch. And we give you a visual creation tool and then a JSON creation tool. And the JSON creation tool is going to be for your more advanced. I've spoken to somebody, or I know exactly what I'm doing because I've worked on Elasticsearch for years. The visual editor is a great way to get started, create a simple dynamic index to just start playing around with it. And that's kind of what I have here. If you want to do full dynamic mapping, it's really just a couple switches, choosing which fields you want to map specifically. And then what kind of type you want to create. So this really just abstracts the JSON view, and I'll show you that as well. So if you go here and go JSON editor, so that's kind of what it looks like in JSON form. So the visual editor is really for I just want to play around, but then when you start getting serious about creating these very large indexes, JSON's probably the way you want to go. And there is a way to test in the UI as well. If you wanted to do a basic search, you could do that right here. If you wanted to do something more advanced, we also offer the ability to pop in a more advanced query here and do your testing right in the UI as well. So it's very, very simple. And I wish the internet was a little bit faster because I would have showed you how to do that. All right, so the other piece of this is monitoring it. How well is my search working? Is it being as performant as possible, and what kind of what is the infrastructure being used by my search process. So when you do create your first search index, if you've seen our monitoring page before on monitoring the health of your MongoDB cluster, there are a couple of specific search metrics that are populated here now. So you can kind of see that over on the right hand. And usually, the ones that I look like when I'm monitoring for clients, and they're creating search indexes for the first time, we like to look at total index size, how much of the CPU is actually being used by the search process, and remember that the search process is deployed with your MongoDB process as well. They're both running on the same hardware. So this is important to look at if you're having, maybe you built search indexes too large because you weren't sure how to do it in the first place, or you didn't know how to be as targeted. This is a great way to take a look at the balance that you're running between both processes, the MongoDB and the Atlas search process. JVM heap, and then, so the other thing too is, so one of the biggest things with the ETL pipeline and kind of what I talked about on my search, my first slide was, you're managing all that ETL, all that uprunning pieces of having something separately attached. Well, replication lag gives you the idea of basically how quickly any changes to underlying collection are being replicated out into a search index that you've built out. So on the primary, it's pretty instantaneous. On the secondaries, just like with regular replication lag in MongoDB, Atlas search follows the same thing. So that's a good indicator too. If you're seeing maybe you have a massively heavy write-intensive load, but you're also trying to have a search index on that, replication lag can give you a good indicator on whether that's being delayed or not. And we can work on that with you as far as establishing other ways to make that quicker and that turnaround faster. Okay. Looks like I'm running short on time. So let me pop back in real quick. And that should load. There we go. OK, so where do you go from here? Well, like I said, I will be over at the Ask the Experts panel later today from 2 to 4. But there's a great way to sign up and get private time with any of the SAs here. Most of us are very capable of answering all your questions on how you might want to do this or implement search for the very first time. So definitely reach out to SAs if you have a question or if you see one of us with a lanyard that says Solutions Architect, we can probably help you. Private consulting time is always a good thing too if you needed hands-on. So say you're like, OK, I'm sold. Let's move everything from Elasticsearch to Atlas. Definitely have some consultants that can help you realign or migrate those queries that you have in Elasticsearch to Atlas. And again, there's plenty of documentation on our website, which I've linked. And I'd be remiss if I didn't say that we have a bunch of mock websites up here. There's 4 right there on screen. Again, I think these decks are being shared after this presentation, so feel free to check those out. One has like a soccer thing. You search for players in many different languages to make your own virtual team. And this was all put together by our developer relations team. So they're here to kind of do those demos and show you what the art of the possible is with search. And if that's not your thing, you can always just read the documentation at the bottom there. We only have a couple of minutes left. But yeah, I'll hand it over to you if you want to kick off Q&A.
Yeah, you want to take a question or two?
Yeah,
we should have time.
I think we have time for like 1 or 2.
All right. Yeah, anyone have a question? And remember, Joe's going to be at the Ask the Experts from 2 to 4.
2 to 4, yeah.
All right.
Hey, so I'm looking into designing a recommendation system, which is a subtle difference between a search system and recommendation system.
Yeah.
And I saw your capability of boosting and other features. So do you have a reference architecture or sample use case for recommendation?
So we do. So I don't know if he's here. So there's a SA that's supposed to be here. His name's Ethan Steininger. He is one of our search specialists. So he's a solutions architect. Specifically, there's 2 in our company, him and Pat. And I'll try and I can get you their contact information. They're very close to the product map on dense vectors and recommendation engines, and they have a couple samples built out already for that. So I'll put you in contact with them. Just come get me after this, and we'll get you talking to them.
One more question?
I was just curious, when you're doing the JavaScript version of the search query,
Yes.
does that always translate back to the UI version, or is there a point where it's too complex?
There is some, yeah, so it tries to do that, but like, the visual tool only has so much in it. So, I think the UI guys are trying to build that out in the visual tool. But yeah, if you're trying to do something more complex, the JSON way is the way to go, for sure. Yeah, I mean, it's pretty pronounced. Like, you can definitely build out quite a bit on there. But yeah, if there's something that you want specifically, let us know and we'll add it in there. We're always open to suggestions on that, for sure.
Awesome. Well, up on the screen is a QR code. You'll see that for each session. Please capture that, give some feedback on each session. Let's have a round of applause for Joe. Awesome talk.
Thanks. Thank you.
All right. Thanks, everybody. We're going to take about a 10-minute break, and then Jeff's going to come up and talk next. You can grab a snack, come right back, or stay where you are. Thanks very much. Awesome.